This is an AC circuit question. You have a diagram on the board. They say, in the circuit given, calculate the inductive reactance. Only the inductive reactance. So let's have chalk. Let's start. Only the inductive reactance, which has to do with this. Okay, this is an inductor, often some amount of inductance measured in Henry. This is a resistor, often some amount of resistance, 50 ohms. So we are expected to calculate only the inductive reactance of this circuit. Okay, and the inductive reactance is coming from the inductor. Okay, this is what we are asked to calculate, inductive reactance. So let's just go. We simply write solution. Okay, the circuit is already given, so that you just look at it and then carry on. So let's see. Let's outline this very well, but it doesn't really matter. Okay, so the next thing we need to do is we consider the formula for calculating the inductive reactance of an inductor. So that is given as XL is equal to 2 pi FL. Okay, so with this, we can now bring out our data. The data there is the inductor has some amount of inductance, 0.7 Henry. That is L is equal to 0.7 Henry. Okay, so what we need to do is what do? We just substitute. What about the frequency? It's not given, or it's not given. Let's just check the question again. The frequency is given as okay, it's given as okay, the frequency is not given. Okay, 60 hertz. Yeah, that's the question. 230 volts. Okay, this is 230 volts, come on, 60 hertz. Yes, okay. Okay, I omitted it. All right, so we have the voltage, 230 volts, and the frequency is 60 hertz. So we have F is given as 60 hertz. 60 hertz. Okay, hertz is the unit of a frequency. So what do we need next? We don't need this. We don't need this. So I think all we need is complete. We have F, we have M now, so we can substitute. XL is equal to 2 pi, all right, times. Frequency is given as 60 hertz times L. The inductor is given as, okay, we can do the other side. If this place is too tight, we can do that the other side. Let's just set the formula. We are going to substitute here. We're going to substitute as XL is equal to 2 pi FL, right? With this, we can find the inductive reactance of the inductor because we have frequency, we have the inductance offered, which is 0.7 Henry. All right, so let's go. At this point, we have XL is given as 2 pi times frequency is 60 times L, which is 0.7, right? 0.7, good. Okay, we can take it again and we have XL, which is the inductive reactance, is given as 2 times pi is given as 3.142 times 60 times 0.7. I hope this is clear. All right, I hope this is clear so that we don't have any part of the board cut off. Okay, so if we do that, very simple. So what do we have here? We have a very simple, we can just do this in a very simple way, 2 times 3,142 over 1,000. Yes, that should be 1,000. 1, 2, 3. Okay, and then times 60 times 7 all over 10. Good. I'm just solving without using calculator. Okay, so that's one thing. So we can simply come here. 10 can cancel this, and we have 2 times, all right, 3.142 here, 6 times 7. 6 times 7 is going to be 42, yes, because 7 times 5 is 35 plus another 7 is 42 times 42. Good. So let's see. What are you going to do? I want to leave the remaining part for you. What you need to do is just press, either you press this, still okay, or you press this. On your calculator, press 2 times 3.142 times 42. Whatever it gives you, put it here in your comments, or rather in the comment section, put it there. You must have solved it, then comment it in the comment box, showing that you've really understood how to find the inductive reactance of an inductor connected in series with a resistance of 50 ohms. Alright, so that is it. Any of these options will fall into play. By the time you finish pressing your calculator and having a concrete value, one of these options must be the correct option, okay? Yeah, thank you for watching up to this moment. I'm signing at this moment. Thank you. See you there in my next class.